Section 6.1 is on solving inequalities and using addition and subtraction when we're working with inequalities. This is just like solving equations, except you don't have an equal sign. Instead, you have inequalities. So here's what I mean by inequalities. These are linear inequalities, which means they're lines because they're linear. This is the verbal phrase. So if we had any numbers, whatever that number may be, less than 2, an inequality would be some number, we don't know what it is, so x is less than 2. So if we're greater than, any number that's greater than, let's say, -2, we'd have some number, we don't know what it is, whatever that is, all numbers greater than -2. So some people get really confused on how to put these signs. The point is always going to point to the thing that's smaller. Here we have numbers less than or equal to. So the numbers, whatever those numbers are the less than, so we're going to point to the numbers, and it's less than or equal to. So or equal to, we put the line. And numbers greater than or equal to, 0, so we're going to point to 0 because we're greater than 0, so 0 is smaller. So those are your 4 inequalities. So instead of equations, we have inequalities. That's the difference between an equation and an inequality. Equation has an equal sign. So just like when we're solving linear equations with equal signs, we use the opposite operations to get x by itself. That's our goal, is to get x by itself. So here's an example. They're pretty simple. 5x plus 5 is greater than or equal to 3. Just like an equal sign, you're going to solve for x. So just like when we're solving equations, you do the opposite to get x by itself. So since it's positive 5, we are going to subtract 5 to the other side. And we're left with 3 minus 5 is -2. So that means instead of x just being one number, it's many, many numbers. Because if I have a number line and I'm at -2, my answer is anything that's greater than -2. So all of these numbers could be my answer. So in inequalities, you have more than one answer, or more than one solution. It looks like one, because I got one number, but it's anything greater than that. So there's more than one solution. Here's another example. Let's try solving x plus 8 is greater than or equal to 1. We do the opposite. It's positive 8, so subtract 8 to the other side. And x is greater than or equal to -7. So on this, my answer would be anything greater than or equal to -7. So if this is -7, my answer could be anything bigger than that. So there's more than one solution here. So here's one that's a little bit more complicated. -2 is greater than n minus 4. If I want to get n by itself, I need to move this -4 to the other side. And since it's negative, I'm going to add 4 to the other side. So now here's the trick. If you move your n to this side, you have to flip your sign. So my suggestion is keep everything in line. So keep my n on this side, keep my sign pointing the same way, and -2 plus 4 is a 2. If I decide to flip this and put the n over here, I have to flip everything. So I would have to flip my sign and then put 2. Because it has to point to the same thing. If I don't switch it, if I just put my n over here and keep the sign this way, this is something totally different. This is n greater than 2, and over here n is the less than because it's pointing to. So you have to flip your sign if you decide to flip it. So these are the same thing. So then graph the solution. You make a number line. And we're looking at the number 2. So put numbers on either side of 2. And at 2, I'm going to have a dot. But here's the thing. It's an open dot. Because it is n is less than. Not equal to, it cannot equal to. It's just less than. So I'm going to shade everything less than. So that's my graph. So I want you to go ahead and try this one on your own. And go ahead and graph the solution when you're done and see what you come up with.